Hello there, professors, colleagues, and researchers from all scientific fields. First of all, I would like to thank you for giving me the opportunity to present a part of my research in the first edition of International Conference on Chemical and Biological Sciences. So, my name is Ouafaa, a PhD student from Abdelmalek Saad University, Faculty of Science, Tétouan, specifically from the Laboratory of Plant Biotechnology. The subject of the communication today is the bioactive compounds from Opuntias for industrial and biological applications. This presentation is divided into a brief introduction, material and methods, results, conclusion, and I will finish by perspectives. One of the major challenges that facing us in the 21st century is the increase in the food and energy demand due to the rise in the world's population. The challenge now is to ensure the use of renewable resources to grow the economy while limiting the impact on the environment and humans. In our research units, we are exploring ways to valorize the bioactive compounds of Opuntias by using fractions or pigments extracted for industrial or biological applications. These valuations can be by direct use of the extract or after formulation in the framework of sustainable development. One of the plant resources is cactus. Opuntia ficus indica is commonly known as prickly pear and belongs to the Cactaceae family. It originates from the arid and semi-arid regions of Mexico. In Morocco, prickly pear is distributed in different regions such as Al-Husaymar, Hamna, Bamran, etc. And the fruits used in this study are from the north of Morocco. For the methodology, I will start by the pericarp powders preparation. The selected fruits were cleaned to remove dust and dirt, then peeled manually. The pericarps were dried in a ventilated oven at 70 degrees Celsius until the weight of the dry matter was stabilized. Then they were crushed using an electric grinder, and the grind was sieved through a stainless steel sieve of 0.2 mm in diameter to obtain a homogeneous powder. Concerning the extraction, the powder has been macerated in distilled water for 6 hours, centrifuged 15 minutes at 5,000 rotations per minute. The residue was then stirred with 70% methanol for 30 minutes and centrifuged one more time for 10 minutes. The supernatant was stored at 4 degrees Celsius. The determination of total polyphenol content is done by the Fullacy-Ocasio reagent method. This method is based on the reducing properties of the phenolic functions. The determination is carried out in the following way. 600 microliters of the extracts are shaken with the diluted reagent, sodium carbonate to 10% and distilled water. The mixture is incubated for 2 hours at 20 degrees Celsius in the dark, and the absorbance is read at 725 nanometers. The range of calibration is prepared from a solution of gallic acid following the same procedure. The content of total polyphenol is estimated in milligrams of gallic acid equivalent per gram of dry matter. For the determination of flavonoid content, stirring 4.5 of the extract diluted with 2% aluminum chloride, the mixture is incubated in the dark for 45 minutes at 20 degrees Celsius, and the absorbance reading is done at 430 nanometers. The calibration range is prepared by the quercetin solution using the same protocol, and the flavonoid content estimated in milligram quercetin equivalent per gram of dry matter. Alright. For the analysis by high-performance liquid chromatography, it was done by concentrating the extract to the rotary vacuum evaporator, and the concentrate obtained was stirred with ethanol 70%, and then the solution is submitted to analysis. Now we move on to the results. The analysis by high-performance liquid chromatography leads to the identification of an abundant compound, apigenin. It is a compound of flavone family, a subclass of flavonoid, with the chemical structure of C15H10O5. It is an antimicrobial and anti-inflammatory agent. To conclude, after the analysis made, it was found that the pericarp of Opuntia ficus indica is rich in phenolic compounds which have many beneficial activities for health, such as antioxidant activity, anti-cancer activity, neuroprotective activity, etc. Among the perspectives of our study, development of extraction and production process of primary and secondary metabolites with biological activity according to the international quality standards, characterization of extract and structure verification by high-performance liquid chromatography, preparative thin layer chromatography, followed by nuclear magnetic resonance analysis, development of the correlation between environmental factor, physicochemical condition, and the content of metabolites in the different parts of the fruits, prediction of the structure-biological activity relationship and the effects of selected molecules, economic study of the industrial importance of the proposed processes, from extraction to biological activity. So that brings me to the end of my presentation. Thank you for listening.